Hey everyone, and welcome to this explainer. Today, we are diving into what is honestly one of the biggest architectural shifts in AI application development right now. We're talking about the migration to the OpenAI Responses API. If you're out there trying to build autonomous agents, multi-step workflows, or really just trying to squeeze every ounce of capability out of reasoning models, like the GPT-6 family, you are in exactly the right place. We're finally moving away from those old, stateless text generation pipelines and stepping into a wildly different future of stateful, tool-augmented execution. So, be honest. Are you still managing your LLM conversation state manually? Because if you're using the legacy chat completions API, you essentially have to carry this massive, heavy filing cabinet of conversation history back and forth across the network for every single request. Every time. It's totally exhausting for the system, it completely eats up your token budget, and it just dramatically slows down multi-turn agent loops. Okay, let's dive into this and contrast the painful old way with the new superpower. In the old chat completions API, it's a fully stateless interface. You're stuck managing a flat array of messages on the client side, and running tools requires these manual, agonizingly slow round-trip network loops. But enter the Responses API. Suddenly, we're looking at a completely stateful, platform-managed architecture. It handles your history, it maintains the context, and it natively executes incredibly fast server-side agentic loops. Here's our roadmap for today. We'll start by breaking down the stateless bottleneck, introduce the Responses API, and then get into the weeds of mastering conversation state, advanced tool orchestration, and optimizing performance, before wrapping it all up with a look at the agentic future. All right, part 1, the stateless AI bottleneck, dealing with context bloat and costs. If you've ever built complex apps, you know exactly what I'm talking about. Passing giant JSON arrays back and forth over HTTP just does not scale when an agent needs to think its way through a 20-step problem. And that is why this number is absolutely critical. Empirical evaluations show that shifting to the server-side state engine of the Responses API yields a 40% to 80% improvement in prompt cache utilization. I mean, that's a staggering jump. Because the server is now maintaining the conversation state for you, your cache hits just skyrocket. That instantly drives down operational latency and massively reduces your API costs. Which brings us to part 2. Enter the Responses API, a fundamental shift. You have to understand, this isn't just a minor update. It fundamentally changes how applications actually talk to models. To really grasp this, we need to learn a new piece of vocabulary, the polymorphic item. Back in the old API, you just had a flat array of messages, right? But in the Responses API, an item is a union representation. It models completely distinct actions like conversational messages, function calls, and even programmatic outputs, all within a server-side loop. By separating these concerns into strictly typed blocks, it completely prevents that messy, chaotic mixing of system, user, and assistant content that used to constantly pollute our history tracking. Let's move on to part 3, mastering conversation state and commanding the platform. Now, while the platform can manage the state for you, you still need to know how to pilot it. We basically have 3 primary ways to manage session history under this new paradigm. First, there's good old manual replaying, which you'd use for highly specific stateless environments. Then, there is the previous response ID. Honestly, this one is the real game changer. Instead of sending the full transcript, you literally just send the ID of the very last response. Remember that heavy filing cabinet? It's like letting the server hold on to the whole cabinet while you just hand it the specific folder label you want to pull from. And finally, for long-term, cross-device persistence, you have the Conversations API, giving you a durable thread ID that lives across entirely different client sessions. But I have a huge warning for you here. A crucial detail to note is the default storage setting. The API actually defaults to opting out of storage for zero data retention compliance. That means store is set to false. If you keep it this way and decide to use manual replay, you absolutely must replay the complete, unmodified output array from the model. You see, deep thinking models output encrypted cognitive markers and phase annotations, things like commentary or final answer. If you try to be clever and aggressively prune the history by dropping these markers, you will actually break the model's internal reasoning process for the next turns. You've got to pass them back exactly as they were received, no exceptions. Okay, part 4, advanced tool orchestration. This is the autonomous powerhouse. What's genuinely fascinating here is how beautifully this simplifies complex back-end orchestration. Instead of you having to write endless, messy while loops in your own code, the Responses API manages this exact five-step flow internally. It handles tool selection, it extracts the parameters, it executes the tool, whether that's on your client or securely on the server, it integrates the output, and then it updates the context. It is quite literally a fully managed agentic loop. While we were exploring this, we actually caught some great insider baseball from the developer community forums. A developer named Yannicka pointed out a really fascinating quirk. In the legacy API, you could easily force parallel tool execution with just a single tool. But in the Responses API, if you have exactly one tool defined and you set the tool choice to required, it defaults to serial execution, just one call at a time. If you actually want parallel execution under a forced tool constraint, you have to either define two or more tools or just leave the choice on auto. It's one of those really interesting implementation quirks you definitely want to watch out for. And another incredible feature we have to talk about is programmatic tool calling. Deep thinking models can now literally write and execute their own local JavaScript inside a highly secure isolated V8 runtime hosted right there on the platform. Just think about what this means in practice. Instead of the model asking to fetch a million rows of data, dragging all of it over the network and processing it, the model just writes a quick script to filter and aggregate that data right on the server. Then, it only returns the final structured answer to you. It absolutely destroys network latency for basic data processing. Let's move to part 5, optimizing performance and cost with some actionable tactics. If you're rolling this out to production anytime soon, here is your rapid-fire deployment checklist of high-yield tweaks. Number 1. Tune your reasoning effort. Do not just default to max. If low works for basic data extraction, use it. It saves massive amounts of thinking tokens. Second, set text verbosity to actively control response brevity. Third, if you have a massive catalog of functions, use tool search. This defers loading them into the context until the model actually needs them. Fourth, leverage built-in native tools like web search or code interpreter, mainly because the models are specifically trained to use them flawlessly. And finally, for those massive heavy analyses, use the background equals true flag. That way your app can just pull a job ID instead of desperately trying to hold a fragile HTTP connection open. And this brilliantly illustrates our next optimization concept, compaction. You know how as an agent runs, old tool logs and intermediate steps just start crowding out the active state? Well, compaction is the fix. It's a context engineering tool that lets the server compress that historical transcript down into a single opaque encrypted item. And to be clear, it's not some loose human summary. It is the pure machine state. It vastly reduces your token pressure while keeping the model razor sharp on its active task. Now, for power users building heavy, multi-step tool loops, you're going to want to pay attention because this contrast is stark. Standard HTTP requires a fresh request per turn, which just incurs massive overhead. But the Responses API introduces a native WebSocket mode. By keeping a persistent connection open, the server maintains the active response state in a warm local memory cache. If you've got workflows running 20 or more tool calls, switching to WebSockets makes your agent roughly 40% faster end-to-end. So for complex loops, honestly, switching to WebSockets isn't just an option, it's an absolute necessity. Finally, part 6, the agentic future and intelligent execution. To wrap things up today, you can see that the Responses API is no longer just about generating text. We are way beyond that. It is evolving into a full-blown operating system for intelligent execution. So as you head back to explore this in your own code bases, you really need to ask yourself a question. Will your next application just be a basic chatbot that answers questions? Or are you ready to build a true agent that executes complex workflows autonomously? The architectural shift is already here. Thanks so much for joining me on this explainer, and happy coding!